Okay, guys, I think we can start now. So good afternoon, everybody. So last week, I started to explain interrupts, okay? And to make it very simple, interrupts means event. Number one, event subroutine, okay? So if I want to summarize interrupts in 2 words, event, and because of this event, we're going to execute a subroutine. That's it, okay? So that is why, if you see here, guys, if you look at this code, I don't to call, there is no instruction here to call the subroutine. That's true. That's true. Because who's gonna call the subroutine is the event hardware. You got what I'm saying? So this is done by the hardware. I think this may be a difficult concept for most of us to understand because this may be new for most of you. Usually, if you have a subroutine, usually you have to call it, okay? In interrupts, yes, we call it, but I'm not gonna write instruction to call it. It's gonna call it by the hardware, okay? Anyway, so that's why, as you see here, for example, after this instruction, you are expecting we are going to execute this instruction. However, if there is an interrupt, so after this one, we're going to go execute this one and then I'll come back. Okay. Then I told you we have several sources of interrupts. I list all of them here. Okay. So, and in this chapter, I'm going to focus only on 2, but for sure, next chapter, we're going to have more. So in this chapter, I'm going to focus on IRQ and also real-time interrupt or RTI. Also, next chapter, we have many interrupts. The good thing, it looks difficult, but the good thing, it's not difficult at all. Why? Because if you learn how can you program one interrupt, all of them exactly same thing. As you will see, we just change numbers, okay? So last time I started to explain IRQ. So number one, what is IRQ? Very simple. In IRQ, for the microcontroller, we have a pin, okay? Every time there is a falling edge or low level, this is something you can program, something you can select based on what you want to do, based on your project, okay? For example, for now, let's talk about falling edge. So every time there is a falling edge here, you are gonna trigger what we call IRQ interrupts. So there is a subroutine for IRQ interrupts. Every time falling edge comes, I'm gonna call this subroutine. And then you can write here whatever you want to do, okay? When the falling edge comes, what do you want to do? Based on your, for sure, this depends on your application. For example, if I want to count, if I have a motor, I want to measure the motor speed, okay? For example, the motor, the way, I'm going to explain later, the motor speed is going to generate some kind of signals this way, okay? So I want to count how many falling edge I have, and then I'm going to use it to calculate the motor speed, okay? I'm going to give you details later, but I'm just want to give you some idea here. So here, in this pin, I'm going to connect a sensor. This sensor should generate based on the speed signal like this one, and I want to count how many pulses we are going to have in 1 second. And then I'm going to calculate, based on this number, I'm going to calculate the speed. So all what you have to do is here, every time there is a falling edge, I'm going to call the subroutine. In the subroutine, I have to increment a counter, okay, to count. You will see right now, or you will see in detail. So anyway, so what I want to say is very simple. So IRQ is, you have a pin here. Every time there is a falling edge, you are going to call a subroutine, IRQ subroutine. That's it. You got what I'm saying? So question here, this falling edge is going to come from where? Okay. For sure, as you will see, it can be coming from a sensor, okay, fire sensor or whatever. Also, as we are going to do, as you will see today, and also as you will do in the coming lab, so this falling edge is going to come from a push button here. Push button. So that's what we're going to do in the coming lab. I'm going to use the push button to generate this one here, so that every time you press the push button, you trigger IRQ interrupt. Okay. So this can come from push button or from the sensor, whatever it is. Okay, now, so where is this IRQ here? It is here, the second pin here. Okay, so if you go to the board, it's actually, let me go to the board here. Yeah, can you see here? BE1, can you see? Oh, maybe I need to use another color. Yeah, can you see here BE1? BE1 here, yeah. So the second one here, this is the second one here, okay? So, so this is external pin, yes, and it's an external pin. Anyway, so, okay, so now how can I program it? So as I told you before, here, for when you program any interrupt, any source of interrupt, we have to do these steps, okay? For all of them. So now I'm gonna elaborate, or I'm gonna give you more details. How can you specifically do these tasks, or how can you do this programming for IRQ, as you will see right now? Okay, so number one, you have to initialize the vector, the interrupt vector, okay? This is, as I said before, you can put your it's a subroutine. You can put it anywhere in the memory. However, I have to tell where it is. So I have to store the beginning address of the subroutine in a fixed location, predefined location. So now in your program, we used to have only 2 orgs, right? We used to do that. We have org 1000, and then all data or arrays are here, and then org 4000. The code is here. Okay. So now you can put here before this one, this org, or you can put it here, this org here. It doesn't matter where you put it. Okay. But it has to be before. So this one should be only 1 block, and this one block. Okay. So anyway, so what I did right now here, guys, is this is, and also this is the name of the subroutine. You can name it any name, but you have to use the name here, okay? So this is the name of the subroutine you have to put in your program, similar to any subroutine. So I have, for example, I'm gonna call it IRQ underscore ISR colon, and then I'm gonna write the subroutine, and then I'm gonna put here RTI, as you will see right now, okay? Again, this is just any name, okay? And then, so as we did before, once you put a name here, the code word is gonna replace it by address, by exact address. This exact address is actually the beginning address of this subroutine. So what I did right now, guys, using this instruction here, what I did is I'm gonna store the beginning address of the subroutine in this location, and next one gonna be a word, okay? So again, when I talk about any other interrupt source, I'm gonna repeat this one again. The only difference is I'm gonna use a different number. That's it. Okay. So how you came up with these numbers from the table here? For example, IRQ, I'm gonna take this one. When the time comes, I talk about RTI, I'm gonna select this one. That's it. Because this is how it is designed. Okay. So the way it is designed, this location is reserved for the beginning address of IRQ. This is how I can tell this is the agreement between the programmer and between the microcontroller. Okay, so they are telling us you can put your subroutine anywhere, but in order to know where it is, so you have to put the beginning address in these fixed locations. Okay, this is the first thing you have to do. The second thing, as I mentioned before, the enable bit. I told you for every interrupt source, there is 1 bit. This bit is going to be used to enable or disable interrupts. Okay. So I have to tell you where is the enable bit. Also, we have to do some kind of configuration, and this configuration is different from one source to another. Here in IRQ, the configuration can be used to trigger interrupts either at falling edge or low level. So we have a selection here, this one or this one. It's up to you, whatever you want. So you have a selection. And because I have only 2 options, so 1 bit should be enough. 1 bit is enough. Is that okay? When I come to the timer and I do configuration, we're gonna have 4 options. And because we have 4 options, so I need 2 bits. to select 4 options. Anyway, so same thing here. We have only 1 bit to select if you want to trigger interrupt at falling edge or at low level at 0. Okay, when what I mean here, when this pin has a 0, you trigger interrupt. Anyway, so where are these 2 bits? Where are these 2 bits? Very simple. These 2 bits are in this register, integer interrupt control, INTCR, and the 1 bit is here. This one is bit number 7 here, as you see it, and very simple. All what you have to do, this one is used if you put here 1, so you actually are gonna program falling edge. If you want to make it low level, you put 0. Very simple, right? Also, this one for enable. So at any time, if you want to disable IRQ interrupt, very simple, just put 0 here. So as you see here, 1 means interrupt is enabled, 0 means it is disabled. At any time, if you want to disable, just put 0 here. Okay, very simple. So in your code, you have to write this one this way. Okay, how you came up with this number? So here I have to write, I have to program this register. I told you similar to what we did before for DDRA, okay, and port B and so on. Yes, we call it a register, but actually it is an address, okay, and it's already defined in the file you include. So how you came up with this one? Very simple. Number 1, I have to put 1 here for sure to enable. I have to put 1 here, okay? And then if I have here to put 1, so now 1 1, okay? So this is for falling edge 1 1, which is C0. That's why C0, okay? If you want to program it for low level, so it has to be 0 1, which is 40. That is why always you put C0 or 40. Okay, for sure, this is if you wanna, if it is enabled. Okay, any questions? And then for sure you have to do CLI, as I said before. CLI, this is the global interrupts. Okay, so this is a global switch. This is bit I in the flag register, as I explained to you before. Also, that's all what you have to do. So in the main program, all what you have to do, guys, in the main program. So this should be outside. This is, as I told you, have org 1000, and then you have to put this one. In the main program, you have to put only 1 instruction, which is this one. Okay, also CLI, this one. Okay, and then inside the subroutine, for sure, any subroutine, you have to end it with RTI, as I explained. Also, you have to write instruction here to clear the flag bit. Please don't forget this. You have to clear the flag bit, because if you forget this, if you forget to write this instruction, you are going to have continuous interrupts. Your program is going to be frozen. Nothing else will be executed. The main program is not going to be executed because all the time it's going to do only one interrupt. The other interrupts also are going to be frozen. Okay. Anyway, so you have to write here an instruction to clear the flag bit, as I explained to you before. However, the only exception is IRQ. You don't need to do that in IRQ, but as you will see later, when I explain any other source, you have to write an instruction to clear the flag bit, because in case of IRQ, it is cleared automatically, so you don't need to worry about it. So now let me show you the first program. How can I program it? Okay. So in this program, what I want to do here in this program, very simple. What I want to do is every time there is a falling edge here, I want to shift 1 LED. So here I'm going to shift, let me shift right or left. Yeah, it doesn't matter, but just to be consistent with what I did here. So here I'm shifting left. So what I want to do, guys, here, this LED is on. Okay. Once every time there is a falling edge come here, so I want to shift it. So now next one is on. When we have another one, so now next one is on. And all the way to the end, and then once I come to the end here and I shift it, so it has to come back to here. You got what I'm saying? So that's, so every time there is a full, and as and what I'm going to use, as I told you, how you are going to generate this falling edge, I'm going to use one push button, as I told you. So every time I press the push button, okay, so actually this LED is on. When I press, next one is on, only one. So only one on at a time, because we shift, okay, until to the end, and then it has to come back to the beginning again. So anyway, let's see how I made this program, guys. So here, as you see, you have this program here, okay, in this file. Number one, I have to do this org, as I told you. I can put it just before org 4000, as I told you. It's okay. This is number one. This is the name of the subroutine. You can use any name, but I just use this name. So this is the main program is here. This part is the main program. Okay, and now I have also this one. This is one interrupt. So as I told you before, and this is confusing to students, okay, please listen to me. So now our program is going to be somehow different from what we did before, okay, even in C language. So how it is different, I'm going to tell you how. Now your program, you have the main program, okay? So the main program also it can have some subroutines. That's okay. So it can have some subroutines. It has include. Do you remember include? We used last time. So it has include. So it can have subroutines. And this subroutine, you can call it from the main, like here, it's something like main function. You can call it and then you can return it back and so on. All of this, I'm going to call it the main program, okay? On top of that, you are going to have interrupt subroutines. So I'm going to have IRQ, interrupt subroutine. Maybe when you learn more, and when we write big programs, we are going to have several of them. One for RTI, one for timer 0, one for timer channel 1, and so on. So you have multiple of them, okay? And what's going to happen is when you first run the program, so automatically you are going to come here to the main. Every time there is interrupt coming from here, it's going to go execute and then come back. And if there is interrupt from, it's going to go and come back. It's going to go and come back and so on, okay? Also, when you have an application, and this application, you are going to have like 3-4 tasks, okay? And you need to decide, so for example, I'm going to put task 1 here, and then I'm going to put task 2 here. I'm going to put task 3 here, so that all the tasks, you run all the tasks at the same time. So today I'm going to do something really very useful for you. I'm going to do the program, the shifting LED program. I'm gonna put it here. And then I'm gonna explain it again, but I'm gonna put it in the main program. I just want to show you one example how the same task I can put it in the main program, or I can put it in one interrupt subroutine. But this is how our program is gonna look like later. Okay. And that's what actually did here. So this is the main program here guys, as you see here. So when you run your program, I'm gonna come here, I'm gonna go all the way to here, and then you have to end, very important, you have to end it either by loop this way, or some cases I'm gonna loop back to the beginning again, okay? Otherwise, if you forget to do that, what's gonna happen is, if you forget to do that, it's going to continue. It's going to continue and go execute this subroutine. It's going to consider this one like a subroutine. You got what I'm saying? So always, guys, for the main program, either I have to loop here, so that once I come here, I'm going to keep looping here, okay? And if there is interrupt, I'm going to go and come back, okay? But I have to freeze the program here, okay? Otherwise, the program is going to go execute this subroutine, right? Or you are going to go to the beginning again. So I'm going to give you more details now, but let's see. So this is the main program, as you see here. This is the main program, and we have only one subroutine here. Only one, as you see here, guys. Okay. You can put any name here, any name, but you have to end it with RTI. Is that okay? So now the program has 2 pieces, 2 parts, the main and this one, okay? So let's see what did I write here in the main. So what I did here in the main, guys, is I have number one, I have to do configuration similar to what we did before. So I have to configure port B. I have to configure port J because I'm going to use the LEDs. I have to configure port P. So this is similar to what we did before. There is no change here, okay? This is similar to what we did. We're going to use the LEDs, so I have to disable the 7 segment okay? And then here I'm gonna write instruction to turn the first LED on, okay? I think, so I'm gonna shift to the left. I think when I explain to the right, it doesn't matter, just I'm gonna be to the left. So here I'm gonna turn on this LED so that every time I press a push button here, I'm gonna trigger IRQ interrupt, and then IRQ interrupt is gonna shift this LED. So from here to here. When I press again, so every time I press, I'm gonna trigger IRQ interrupts, and then in the interrupt subroutine of IRQ, I have to write a command to shift the LED, right? So once it comes to here and you shift it, so it has to come back to here, as you will see right now. Okay. So let's see. This is the main program, guys. Also here, this is what you have to write related to IRQ interrupts. That's what I told you here about this one. Okay. Also here, you enable all interrupts. Once you do that, once you do this two steps, guys, now IRQ interrupts are ready. Interrupts can happen at any time. So once I enable interrupts here, once I do this one, so interrupts are ready. That is why usually you should put this instruction at the very end. After you finish all initialization, you should enable interrupts. Otherwise, if you don't do that, if you enable interrupts in the beginning before I finish the initialization of the other things, as you see here, maybe interrupt is going to happen. So once I read these two instructions, guys, interrupt can happen at any time. So you should be wise here. Number one, you have to finish all the initialization we have, and at the very end, after you are done, now you can enable interrupts so that I want interrupt to happen here. I don't want interrupt to happen here, and I didn't configure port B yet. You got what I'm saying? That's what I want to say. Okay, and then here, because this is just a very simple program, the main program, this part, here I actually run only one task. This task is written here, written in the interrupt subroutine, okay? The main program doesn't have another task because this is just very simple. However, you can remove this one and you can put any other task here, like for example, the keypad and LCD lab. So the keypad LCD lab, you can put it here, or any other task as we'll do in the future. But now this is just a very simple program. The main program is not doing, I don't put anything in the main program, but in the future, it's free. You can put any other task there. Okay. Anyway, in any way, your program should not come this way. So either it has to go back or keep looping this way. Okay. Anyway, so what's going to happen after I finish all this initialization, I'm going to keep looping here. Okay, and then every time there is interrupt, I'm gonna go execute the interrupt subroutine and come back, go execute and come back and so on. Okay, again, don't be confused. It's just a very simple program. I don't put anything here in the main program because this is just a simple program. One more thing, guys, I told you, as I'm gonna explain, we have here on this board, we have 4 push buttons, as you see here, 4 push buttons. Okay. How these push buttons are connected, I'm going to tell you how. So very simple. As you know, guys, as I explained before, we have port H. Okay, I told you port H has 8, 1, 2, 3, 4, 5, 6, 7, 8. It has 8 pins, and in every pin we connect a switch, right? As we did before. Yes, we connect a switch, right? For every pin we connect a switch. Is that okay? As we did before. Also, in the first 4 pins, PH0 to PH3, also we connect push buttons as well. So in the first 4 pins, in every pin we connect a switch and push button. Okay. You may ask me why you did this way. Again, they did it this way because this board is for education. They want to put too many things, okay? But for sure, if you want to do your own project, you should not do that. You got what I'm saying? So you should either use the switch or the push button. You cannot, at a certain time, you cannot use both, as I'm going to explain right now why. So the way it is connected, so let me say it again. Port H, we have 8 pins. Every pin has a switch, and we already used it before, okay? Also, the first 4 pins, we have also, in addition to the switch, you also have a push button, okay? And usually you should use one of them. You cannot use both, okay? So how it is connected, I'm gonna give you one example for one pin, for example, and then you can understand it well. So here, this is the way it is connected, guys. If I get one pin here, so it's connected this way, you have resistance, and then you have 5 volt here, okay? And then here, you have here a push button this way, and we have ground this way. Also, it has a switch this way, and then you have ground this way. Is that okay? So if the switch is open and the push button, if you don't press the push button, so here, very little current is gonna go this way, and this one will be 5 volts. That's why you are gonna get 1. So if I read the pin, if you read the pin and it is 1, it means the switch is open, and also you didn't press the push button. Is that okay? Also, as I explained last time, if you connect the switch this way, so now this one is a current is gonna go this way, and now this one is 0 volt, and now you are gonna read it 0, as I explained to you before. So if the pin is 0, that means the switch is connected. The same thing is gonna happen when you push. So when I push the button, this way, I'm gonna actually connect it this way. So 0 is gonna come here, and then you are gonna read 0. Is that okay, guys? Very important thing is, very important thing is, okay, if I wanna use the push button, you have to make sure the switch is open. This is the source of a common mistake. Many students write the program, look, it's not working. Yes, the program is not working. Why? Why you have to make it's open? I'm gonna tell you why. Because if the switch is connected, okay, so there is 0 here all the time. So if I press or you don't press, it's not gonna have any impact. You get what I'm saying? Because the 0 is coming from the switch, it's not coming from the push button. So many students run the program and tell me, look, if the program is correct, I run it, it doesn't work, okay? It doesn't work. So look, when I press the button, it doesn't do anything. Yes, because you forget the switch connected. So it's connected to 0 all the time. Okay, guys? So you have very important thing. If you want to use the push button, you have to make sure the switch is open. So that here, it's 5 volt. When I press the button, it's going to be 0 volt. When I release, it's going to go back to 5 volts. That's how it should work. Look here, guys. This is how it should work. It should be 5 volt. When I press the push button here, the push button is going to go to 0 volt. And then here I hold. And then when I release, it's going to go high again. You got what I'm saying? That's how it works. So every time when I press, I'm going to connect it to 0 when I press. When I hold, still 0. When I release, it's gonna go back to 5 volt. You got what I'm saying? So again, the only way to get a signal like this one, you have to make sure this one is open. Okay. You know, push button is different from a switch, guys. That's because the push button has a spring. Inside it has a spring. When I press, I connect. Once I release, so it's gonna disconnect. Right? This is how they work. It's different from a switch. How? So every time I press, I'm gonna make something like that. Every time I press and release, I'm gonna have something like that on the pin here. Is that okay? However, the switch is different. It's a switch. If I change the location of the switch, so it's gonna be 0. It's gonna continue 0 forever until I change the switch again. So for example, if I put the switch here, it's going to be 0 all the time, right? So once I return it back, it's going to be 5 volts. This is different from the push button. Push button, when you press, you are going to make it go down. Then once you release, it's going to go up again. Okay. So I can say it in a different way. In case of push button, it's 5 volt all the time. All the time it's 5 volt, unless only during when you press and you hold, it's 0 volt. Got what I'm saying? So anyway, this is how the switches are. So again, we have 4 switches, guys. These 4 switches are connected to PH0 to PH4. Also, they are connected to switches here. You have to use one of them at a time. You cannot use both of them at the same time. That's why if you wanna use a switch, you have to make sure the switch, if you wanna use push button, you have to make sure the switch is open, okay? Again, based on what I explained here, guys, is just to make it very simple. So now, forget the switch. I'm not gonna talk about the switch. Now I'm gonna focus on the push button. So every time I press, if you look at the signal here, for example, I'm gonna use PH0. For example, you have PH0, 1, 2, 3, 4. You have 4. You can select any one of them. For example, I'm gonna select PH0. Okay. So when you select PH0 here, guys, this is how it works. It is 5 volt. When you press again, and that's it. So press and release. Is that okay? Okay. Any questions? You understand now how every time I press and I release, I'm gonna generate a signal like this one. This is one press, second, third. Any questions? Now, if I take this signal, so now we agree. Every time I press, release, press, and release, I'm gonna generate a signal like this one on PH0. Is that okay? Now, if I connect a wire, this is PH0. If I connect external wire between PH0 and the IRQ, what's gonna happen? What's gonna happen is this signal, I'm gonna connect this signal to IRQ. So this signal is gonna be generated here, and then this external wire is gonna connect it to IRQ. That is why every time there is a falling edge, I'm gonna trigger interrupt. You got it? Okay. And that's what we're gonna do in the coming lab. So in the coming lab, you have 4 switches. You can select one switch, PH0 or 1 or 2, whatever you want to select is okay. And then you have to connect external wire so that every time I press a button, this signal is gonna come to IRQ. Okay. How you will do it? Let me go to, yeah, for example, here, look here, guys, pretty simple. Yeah, let me change the color here. Yeah, so here, this is second one is the IRQ, which is B. I told you this is PE1. PE1 is the second one. So you can, from here, second one, okay, second one. So here, you have to connect the second one here. For example, where is PH0? For example, I'm gonna use PH0. So I have to connect a wire from here to here. Okay, if you wanna use PH3, so it has to be from here to here, external wire. Okay, so that the signal, when I generate a signal like this one, every time you press, for example, every time I press a button here, I'm gonna generate a signal like this one. The wire is gonna transfer it to here so that you trigger interrupt. Is that okay, guys? Okay, is that okay? For sure, in other application, you may have a sensor. It doesn't matter where the falling edge comes from. Very simple. Every time a falling edge come here, you trigger interrupt. Is that okay? So anyway, now let's see. So now the question is, how can I program? How I can program this one PH0 or this one? Is that different from what we did before? The answer no, it's not different. It's just one pin. This pin has to be output instead of not input. It has to be output. So the same programming you did before for a switch, it's gonna be the same way like this one. Okay, that's why if you look here in this program, guys, as you see here, I just did programming here this one. Okay, let me think I have. Okay, look here how I yeah, so here I programmed all of them. Input, right? Sorry, it should be input. So I programmed all of them input. You don't need all of them for sure in this program, but I just did all of them because I don't care about. If you want to program only one of them, so you have to use BitClear as I explained before. Anyway, so here I program. This is similar to, again. So what I want to say is that the way you are gonna program the push buttons are gonna be the same way as we programmed the switches before. Is that okay? Any questions? Okay, now let's return to the program here. So this is the main program here, guys. Once I finish the initialization this way, so here, so actually, once I do this one here, I'm gonna tell the IRQ that where is the subroutine. Also, once I finish these two instructions, now it's ready. Okay, and now it's ready now. That means every time there is a falling edge, the subroutine will be called. Okay, and then do whatever you want to do. So what I want to do here in this application, look, guys. So what I want to forget this part for now. I'm gonna explain it in details, but forget it for now. It's not essential now. So here, again, keep in mind. I just want to make it easy. Just keep in mind, every time there is a falling edge, this will be executed. Is that okay? So look here. It's gonna happen. What's gonna happen here? Number one, you are gonna shift port B. You are gonna shift port B to the left because that's what I want to do. What I want to do, if this one is on, I'm gonna shift it this way to the left, one step. So I'm gonna shift it to the left. Is that okay, guys? And then if I shift it all the way to the end, so I have to return it back to here. Okay, that's what I'm doing here. So now I'm gonna say shift it to the left, and if it is not zero, if it's not equal to zero, okay, so that means you have to jump it to here, and then RTI, I am done, right? If it is zero, so it's gonna go this way. If it is zero, when it is zero when this one is on, and then you shift it. So now port B is gonna be zero. Port B is gonna be zero. Is that okay? If it is zero, so now I'm gonna return it back, turn this one back on, right? So that every time you shift all the way to here, and then it's gonna go back to shift again, and so as you see here, guys. Any questions? So number one, I'm gonna shift. Number two, I'm gonna compare it. If it is not zero, I am done. If not, come here to turn the first one on. Is that okay? Any questions? Okay. I'm gonna tell you the good thing. The good thing is, look here, guys. Now, what if I want to change the functionality of this program? I want to do something else, okay? All what you have to do, guys, just to change this part. That's it. So that's what I'm saying. If you understand how can you program interrupts one time, all of them the same. The only difference you may make is, as I told you before, here I programmed it for falling. Maybe in other application you make it low, okay? So what I'm saying, every time, if you want to make it for falling edge, okay? Every time you want to use IRQ, just copy and paste. That's why I'm saying programming is easy. Programming interrupts are easy. All what you have to do, guys, is by changing the application, all what you have to do, just I'm going to change what I wrote here. That's it. Give me example. I'm going to give you example. Look here, guys. I'm telling you here, if I just change what I wrote here by this instruction, now I have a completely different application. For example, look here. Here, if I'm going to toggle LED, as you see here, I'm going to read port B, I'm going to toggle it, and then return it back. You know, if I do that, what this application is going to do? Okay, think about it. So again, every time you press the push button, you are going to generate falling edge. You are going to execute this subroutine. This subroutine is going to, as you see here, is going to flip the LED. That means if this LED is on, I press the button, I'm going to make it off. Press again, I'm going to make it on. Press again, is going to make it on, off, on, off, off, on, off, and so. So that's what I want to say. Just always you are going to use the same program, but just you are gonna, whatever you're gonna write here is gonna be different, okay? Also, as I told you before, look here. If I wanna count, for example, I told you this IRQ should receive falling edges. Actually, these falling edges can come from different sources. For example, I'll give you example. There is one way, if I want to count, for example, the number of cars driving over the road, if I want to count the number of people who enter the store, for example, the way we do it usually is we can put here infrared IR, infrared transmitter, and we have here infrared receiver. Every time light, you cannot see this light. So every time you enter a store, you are gonna cut this line. Once you cut this line, you are gonna generate a pulse this way. So if this pulse, just to go to IRQ, that means it's one customer entered the store. You get what I'm saying? So every time I receive a pulse like this one, that means one customer enters the store. So if I want to count the number of people who enter the store, all what I need to know how many interrupts you got. That's it. Because every interrupt means one person. You got what I'm saying? So all what I have to do here, guys, as you see here, every time there is one interrupt, I'm going to increment a counter. Okay? Increment a counter. And then I can display this counter on port B, or you want to display it in the on the 7 segment, as I'm going to explain later, or in the LCD, wherever. So every time there is one interrupt, you increment a counter. Very important thing. This counter has to be a memory location. It cannot be register. It has to be a memory location. Why? You remember, okay? Because if it is a register, every time it's going to take the initial value back. Okay, because as I explained before, once there is interrupt, automatically all the registers are going to be pushed to the stack. Original value is going to come back, right? So if you use a register A or register B, so if the initial value of A is 0, it's going to continue 0 forever, because every time you increment, once I leave the subroutine, I'm going to put the initial value back. You got what I'm saying? So anyway, so if you want to remember something like that, if you want to recall how many interrupts, so it has to be a memory location. Any questions? Okay, so now what I want to explain now, guys, is, okay, I'm going to explain how we can do the same thing using, any question here using C. But before I move to the C, do you have any question? Very simple. So all what you have to do, you have to write this one, you have to write these two. The only difference is that you may put here a different number. This is the only difference. And then you have, for sure I'm going to explain this part, but then you can write whatever you want to write here based on what you want to do, okay? So I'm going to explain. The interesting thing here is, as you will see, after I finish the C language, I'm going to explain how can we do the same program, but I'm going to put it in the main program, not interrupts, without interrupts, okay? So you will see, I'm going to use exactly same code. However, I have to write some code to check if the bit is 0 or not. Okay, so let me do it now before. I just want you to understand. So what I'm gonna do right now, guys. So again, what I did so far. Every time I press a button, you shift LED. Is that okay? That's what I did. Now, I wanna do the same thing without interrupts. So all what I'm gonna do, guys, is I'm going to use the same code, the same program, the same code here. However, I have to check. So I have to check if the bin is 0 or not. Are you 0? No. So do nothing. Are you 0? No. As you will see right now. Okay. Here, so I'm going to explain how can you do the same program, the same task, but I'm going to put it in the main program, and I want you by yourself to compare between both of them using interrupts and without interrupts. So before I take questions, let me go to here. So here I'm explaining here in chapter 3. Let me go where it is. Okay, so this is the program here, guys. Yeah. So this is the program, the same program, but I'm gonna put it in the main. I'm not gonna use interrupts. I'm gonna do the same thing, but without using interrupts. Look here, guys. This is just definition. So this is just initialization. Even if you use interrupters, you have to do the same initialization here. So it's exactly the same initialization. However, most of the time the program should be here, or most of the time I'm here, because you are going to keep looping here, as you will see right now. So if you go back here, you are going to loop to here. So all the time I'm going to loop here in this part. So this is initialization for port P, for LEDs, for port H. So I did the same thing. So if you have interrupts or not, should be the same. But this is a program here. Look at what I made here right now, guys. So all what I'm gonna do is, I told you, every time you press a button, there is a signal like this one. Okay, so I wanna see if there is a signal or not. So the way I did it, as you see here, guys, I'm gonna check this pin. As you see here, I'm gonna check the pin. If this pin is high, is 1, what should I do? Nothing. You didn't press, right? So that's what I did here. Look here. I'm gonna check this pin. If it is high, so just keep looping here. Pulling. That's what I explained last time. No interrupts. I'm doing pulling. You got what I'm saying? Continuous check. So here I continuously check the pin. Are you 1? Okay, nothing. Are you 1? Nothing. Are you 1? Nothing. Once it is 0, I have to come here. And once I come here, that's exactly what I did before. You have to shift. You have to shift to port B. And then if it is not equal, come to here. If it is 0, you have to put it back to here and then go back to check again. You got it? So if you compare this program with interrupts, so here I want you to learn 2 things. Number 1, usually, one task, I can do it. I can put it in the main program, or I can put it in interrupts. It's something I need to decide, okay? And sometimes it doesn't make big difference, but anyway, this is something you need to decide. If your program has 3, 4 tasks, you have to decide which task has to be in the main program, which task has to be in like IRQ or timer or whatever, okay? This is number 1. Number 2, you should understand why interrupts are so awesome. They are so awesome because the difficult part is done by the hardware, not by me, but not by the code. What is the difficult part? If there is a signal or not, if you press or not. You get what I'm saying? Here, I have to write a program here to check if you press or not. But in interrupts, I didn't need to write a code to check if you press or not, because this is done by the hardware. Okay, that's why it's much simpler than this one. I'm gonna talk about this part, but just okay. Any questions? Yes.
I have a question about the interrupts. How do you tell that interrupt to look at port H instead of a different port?
IRQ has, okay, I just want to make sure I understood your question. IRQ doesn't care about port H, it doesn't know, it doesn't care. So for IRQ, it has 1 pin. Once I have a falling edge, okay, once you have falling edge, you are going to trigger interrupt. Even IRQ doesn't care where this falling edge is coming from a sensor or from a switch, it doesn't care. You got what I'm saying? Just so here we have, for example, I'm going to use PH2. I told you we can use PH0 to 3. So I'm going to use PH2, for example, okay? This is a different story. So in PH2, every time I press a button, I'm going to generate a signal like this one. Okay? So now I have to connect a wire this way. When I connect a wire this way, the signal is going to come to here. When it comes to here, every time there is a falling edge, you trigger interrupt. So I didn't tell, so based on my understanding of your question, I didn't tell IRQ, you have to take the signal from I didn't write a code to do that. The wire is going to connect. If you have a signal, okay, this electronics, it has nothing to do with programming, right? So you have a signal, you connect a wire. So you actually transfer the signal from here to here. Did I answer your question or still?
I understand how it works, but how do you tell it where to connect the wire?
Oh, how I connect the wire?
Yeah.
So it has to, for example, if I use PH2, first you have to decide which switch you have to use. So let me go to the board. Yeah. So for example, here, I'm going to use BH3, right? So BH3 has a pin here. Maybe the picture is not that good, but it has a pin here, right? So you have to connect it from here to here because this is IRQ. The second one, just the second one. So you have to connect the wire this way from here to here. Jumper. That's what I mean. Maybe you confused when I said wire. Wire here means I mean jumper. Just a wire, jumper. You got what I'm saying? Yeah, external wire. You connect one pin to one pin. You got what I'm saying? Jumper, yeah, external jumper. Or wire, whatever you want to call it. Okay. Any questions? Okay. Now, yeah. So I want you to see the two programs to understand how interrupts are different from if you write the same task in the main program. Okay. So now I want to explain how can you do the same thing I have just explained right now, but using C language. You are not going to see big difference when I talk to C language. Okay. Number one. So again, you are going to have here in C language, we have the main program is here. So this is the main program. For sure, if you have subroutines, you can also add some subroutines here. It's okay. Okay. All of this, I'm going to call it the main program. Also, we have here a subroutine. That's what this is the interrupt subroutine here. Okay. So how you are going to define the interrupt subroutines? That's what I'm going to say. You have to use the word void. You have to use this. You have to use it. You have to use the word interrupt because this is instruction. You have to use it, right? You have to use number 6 because number 6 is this number. So for any interrupt, I am going to use this one. For any interrupt, I am going to use this one. But this number is going to tell which interrupt is that. So for every interrupt, I'm going to use a different number. You got what I'm saying? So 6 is for IRQ. Here you can use any name. It doesn't matter. So here, so microcontroller here is going to know this is for IRQ, not from the English name IRQ. This English name for you, right? But it's going to know this is IRQ interrupt. It's going to know it from this number. Is that okay? So by changing the number, you are going to program a different subroutine. You got what I'm saying? So again, you don't need to do something like that. You don't need. Instead of doing something like that, instead you are going to just use a number. You got what I'm saying? So just you tell me which subroutine is that from the number. So how can you come up with this number? How I can get it? Okay, I'm going to tell you very easy. I'm going to tell you how can you get it. Okay, so the way you can get it. So here, actually, here is going to be the same number you have here. This number 6. I think you start from 0. Let's see, 0, 1, 2, 3, 4, 5, 6. Yes. Okay. So that means RTI has to be 7. Did you get how I get the number? Yes. So this number, it depends the number of, so for timer 0, you have to use number 8. Okay. This one has to be 9, 10, and so on. So this number can tell the C language which interrupt is that. Very simple, right? So here for IRQ, because we start from 0, 0, 1, 2, 3, 4, 5, 6. So here's this number 6, and this one, when the time comes and I explain RTI, I'm gonna use number 7. Is that okay? So the first difference between C language and assembly, in assembly you have to do something like that. In C language, you don't need to do that. Or we're gonna do it, but in a different way. The way you are gonna do it is you just here use a number here. Okay. Again, this is the interrupt subroutine as you see here, guys. This is the interrupt subroutine here. Okay. You have to use the word void. You have to use the word interrupt. You here for IRQ, you have to use 6, and then here you can any name. Okay. For sure, because this subroutine for IRQ, I'm gonna call it IRQ interrupt subroutine, right? But it can be any name. Okay. So if I call it RTI, that doesn't mean it's RTI subroutine, right? I'm confusing myself. The microcontroller is gonna take it for IRQ because you are using number 6. You get what I'm saying? I know I'm keep repeating this part because I know sometimes students are confused when I use a certain word. They think this is instructions. That's why I'm very clear what is instruction and what is can be any word. Okay. So anyway, so and then here, whatever you want to write here. So every time there is a falling edge, you are going to execute this part. So this is the first thing you have to do in IRQ. This is the first thing you have to do. Now let's see now what you have to write here in the main program. As you see here, guys, PLL initialization, we always do that. 7 segment disable, LED enable, we always do that. DDRH0, you initialize, you configure port H as input, right? Also, port B is equal to 1. So actually, by doing that, I turn the first LED on. Okay. So I turn the first one on. I turn the first one on. Okay. And then I can just use this one, IRQ enable. You know what IRQ enable is gonna do? What IRQ enable is gonna do is actually, it has this instruction inside it. As I explained to you before, every instruction I teach in C language, you can open, every function I explain in the C language, you can open the function, you can see how it is written in assembly, as I explained to you before. Okay, so if you go inside this function, you will find it is defined this way. However, because this created a problem before, I want you to pay attention to this one. As far as I remember, it is not the initial, it is not programmed for falling edge, but it is programmed for 0 level. That is why it has number 40 instead of C0, 40 instead of C0. So here, if you use this function, guys, this function should trigger IRQ as low level. Is that okay? Now, what if I wanna program it for falling edge? Okay, I can do something like that. Very simple. I can do something like that. Is that okay? I can say INTCR equal whatever C0, like what I did here. You can do so. You can remove, instead of writing this one this way, you can just use this one. Is that okay, guys? It happened. I think we had this problem before. I think it was in test 2, sorry. In test 2, student just used this one, and it was supposed to be like at the falling edge, but this one should be programmed at the 0 level. Also, in very few cases, for some reason, I really don't know, in very few cases, the microcontroller didn't accept this one. It didn't work. For most of the students, it worked for most of the students. But in some boards, for some reason, it didn't work, okay? So in this case, I asked the students to go inside this function and to change. So if you go to inside this function, you will find this instruction. So you can go inside this one and simply you can change this one to C0. If you go inside, you will find it's 40. You can just change it to C0. You got what I'm saying? Very simple. So I would suggest, so let me make it very simple. What I'm saying, guys, is here, if you use this one, okay, if you use this one, you actually program it at low level. Okay, if you want to program it at falling edge, so you can try this one. If it still doesn't work, all what you have to do, you have to go inside this function, it change it from 40 to C0, and should be okay. Okay. Anyway, so but for most of the students, this one worked before. Anyway, so let me tell you the conclusion. Very simple, very simple. Look what I did here, guys. In order to program IRQ in C language, number one, I have to use this one. Okay, that's it. And then you have here to use a subroutine this way, you have to put here number 6. That's it. Look at that. So now I have, as you see here, I have here infinite loop. So all the time if there is interrupt, I'm gonna go and come back, go and come back, go and come back. Okay. So now what I'm gonna do here is similar to what I did before. As you again, forget this part, I'm gonna explain it in details. Okay. So what I did here, for guys, if you see here, every time there is an interrupt, number one, I'm gonna shift to port B. As you see here, this number one, shift to the left. So this one is exactly equivalent to this one, shift to the left. And then if port B is equal to 0, so I'm gonna make it 1. So if you shift all the way this way, I'm gonna put it back here. That's it. Any questions before I explain why I put this code here? Any questions? Very easy, right? So again and again, the good news is when I explain RTI right now, it's going to be exactly the same thing, but instead of number 6, it's going to be number 7. That's it. Also here, the same thing. I'm going to do this one, but instead of this number, I'm going to put a different number. And instead of initialize this register, I'm going to initialize a different one. You got what I'm saying? So it's almost the same thing, okay? Very close. All of them are close to each other. Any questions? Okay. Now, if now I want to justify why I have this part here. Why I put this part here? Why I have this code here? Okay. Same thing. I use this code here. Okay. I'm gonna tell you why. The reason is very interesting. The reason is the way I'm expecting it should work is every time you press the button, the push button, okay? So you have to generate a signal like this one, and you have to shift one time. That's what you are expecting. Is that okay? So based on our understanding to this code, the way it has to work is every time I press the button, okay, I'm gonna generate a signal like this one. This signal, I'm gonna generate it in port H, like for example, on pin 0 or PH0 or whatever, and you have external wire to transfer it to IRQ. Okay, and then I'm gonna trigger one interrupt. So every time I press one time, I'm gonna trigger one interrupt, and this interrupt is gonna shift one time. That's what you are expecting, right? But this is not gonna happen. Why is not? So if you run this code, what's gonna happen? What's gonna happen if you run this code is when I press one time, the LED is going to be shifted 3, 4, 5, 6 times. 1 time 3, 1 time 5, 1 time 6, random. It's not one. It's going to be shifted more than one time. Why? It shouldn't be this way. I'm going to tell you what happens. Okay, guys? So understand the problem now? The problem is that without this code, okay, that's why I put this code here. I'm going to explain it. Very interesting. So what I'm saying is that that's what you are expecting. Every time I press a button, signal like this one should be generated. And then, and this one is going to trigger interrupt only one time because there is only one falling edge, right? And this is going to shift the LED one time. I'm going to show you a video right now. Very interesting. I'm going to choose a video with and without this code, okay? To understand what I'm saying right now, okay? However, if you run this program without this code, what's going to happen is every time I press one time, I'm going to see the LED shifted 3 times, 4 times. Why? Simply because when I press one time, I'm going to make 3 or 4 interrupts. Why? I'm going to tell you why. You got what I'm saying? So the reason is, let me clear this one. The reason is, I told you guys, if this is, for example, PH0, is that okay? I told you every time I press, it has to be something like this. You press one time. Then when you press again, it has to be something like that. If you press again, it has to be something like that. This is not going to happen. This is ideally. So ideally, this should happen. In reality, this is not going to happen. Why? Because the switch has a spring, has mechanical parts. Mechanical parts cannot open and to close immediately. So there should be some kind of bouncing. So when you open it, should be bounce, connect, disconnect, connect, disconnect, and then it's gonna stay here. If you close, if you press, same thing. It's not gonna press immediately. There should be, because the spring is gonna be some bouncing, and because of this bouncing, this is the real signal I'm gonna get. What I'm gonna get, there is a bouncing this way, okay, before it becomes 0. So here at this part, and then bouncing before it becomes 1. So it's not going to be this way. There should be some bouncing. Okay, then bouncing 0, bouncing 1. This bouncing, I think it is around 5 to 10 milliseconds. It's going to bounce for 5, 10 milliseconds. Is that okay? Again, so what I'm saying, this is ideally, but actually in reality, because of the mechanical parts and the spring, you are gonna get a signal like this one, because connect to disconnect for just 5 milliseconds. Okay, so for sure, I cannot say that you pressed 3-4 times here. I cannot say that because there is no human being that can press 3-4 times in 5 milliseconds. You cannot do that, right? This is just because of the mechanic. So I'm not gonna be confused if this happened because of bouncing. That's what we call bouncing problem. So this problem only happens in mechanical switches, right? So I'm not gonna be confused if this bouncing because of the mechanical parts, or this is because you pressed 3-4 times. For sure, you didn't press 3-4 times because there is no human being that can press 3-4 times. Is that okay? So how I can solve this problem? First, is that a problem? Yes, it's a problem. You know why it's going to be a problem? Why? Because what's going to happen is that you are going to have here, guys, one interrupt here. You're going to go execute the interrupt. You're going to come back from the interrupt. This one is going to count another interrupt here, another interrupt here, and so on. That's why when you press one time, it's going to be taken as if you press, it's going to trigger 3-4 interrupts. Every time there is a falling edge this way, it's going to be taken one interrupt. You got what I'm saying? Okay, how can we solve it? Very easy. There are some hardware solution. I'm going to explain them later, but for now, I want to focus on the software solution. So software solution is very simple. Very simple. What I'm going to do, guys, is that once it is zero, I'm going to wait for 5 or 10 milliseconds. Wait, just to bypass this one. This is the first instruction. So the first instruction I'm gonna write here. Let me come back here. That's why that's what we call deep bouncing. I want to cancel the bouncing. So the way I'm gonna do it here, guys, number one, as you see here, I'm gonna wait for 20 milliseconds. 20 may be too much, but you can try it. You can try. Okay. Usually it's between 5 and 10, but maybe this is different from one switch to another. So once it is zero, once I get interrupt, as you see here, I'm gonna wait for some time. Why you are waiting? Because just I want to bypass this period of time. I want to bypass it, and then I'm gonna keep looping here. I'm gonna wait until you release. Okay. So here, once you press at this moment, I'm gonna come to the inside the subroutine here. Then first of all, there are some bouncing here. So I'm gonna wait for them, and then you hold here. Okay. So here I'm gonna wait until you release, because I'm not gonna shift until you press and release. After that, I'm gonna shift. You got what I'm saying? So once you press, I'm gonna wait 20 milliseconds to bypass this period, and then look here. I'm gonna keep, as long as it is zero, I'm gonna keep looping here. As long as you hold, I'm gonna wait until you release. Okay. I'm here using port E, right? Because IRQ is actually connected to port E pin number 1. This is IRQ. Is that okay? So here, port E. So it's gonna be this way. And then after that, as you see here, after that, once you release, once this one is high, so I'm gonna come this way. Once it is high, I'm gonna wait another 20 milliseconds to bypass this one. Is that okay? Pretty simple, right? So I have to wait here until I pass this one, and then I'm gonna wait until you release. Once you release, I'm gonna also wait 20 milliseconds. So as you see here, guys, this code has 3 pieces, 3 parts. One part here, one part I'm gonna wait until you release, and then one part here for the last one. Is that okay? Here, if you go to C language, I did the same thing here in C language. I'm gonna wait some time. Here I put 25 milliseconds. I don't know, you can try. So you can try 5, 10. If it works okay with 5 or 7 or 8, it should be okay. You know what I'm saying? Just put 20 or, and then I'm gonna wait until you release. I'm gonna explain this function later. This is just a function. This function should return true or false. So as long as it is down, as long as you press down, so it's gonna become true. right? So here I'm gonna keep looping here, and then here I'm gonna wait another 25 before I come here. So this code is called debouncing code to solve the problem of bouncing. I want to tell you something very interesting. So I think in one test, test 2, I think in 1 year, 1 semester, we connected IRQ to function generator. Okay? So if you connect IRQ to a function generator, you actually don't need this part. You don't need it. You got what I'm saying? Why? Because the output of the function generator is pure, unless it has some ripple or unless it has some bouncing. But usually it doesn't, right? So you don't need this one. So we only use this code for push button. So anyway, I wanna show now this program. I wanna show the video. All what I'm gonna do in the video is I'm gonna write it twice, as you'll see in the video. One time with debouncing, and the other one without debouncing. You should observe if with debouncing, it works very well. Every time I press one time, it's gonna shift one time. However, if I don't put this code for debouncing, you will see in the video, every time you press one time, okay, and I release, it's gonna be shifted 3-4 times. Okay. This one now.
I press the push button number 3 over there. Look how it is very smooth. Look how.
So this program without interrupts, but it should be with interrupts, should be the same thing. No, there is no difference. But anyway. So once I come to the end, it's going to go to the beginning again. It's very smooth. Every time I press one time, it's going to be shifted one time. Now I'm going to remove it, and you will see what's going to happen.
Here, very, very smooth. Just quickly, I want to show you if I cancel, I'm going to come to this part, the part that has the part that can cancel the bounce. What will happen?
So now I'm commenting this part here and run it. Okay. Look, it's gonna when I press one time. Look, I press one time, it's gonna be shifted 3, 4, 5 times.
Look what happened.
So shift all the way and then come back, right?
It's gonna take more than 1 press.
So anyway, okay, guys, any questions? Okay, now we have some time here, so I'm gonna talk about RTI again. It's very easy. I'm gonna just repeat what I said, but it's gonna just change numbers as I told you. So now I'm gonna talk about another source of interrupts. We call it RTI. Number 1. How RTI is different from IRQ? Very simple. IRQ, it has external pin. Every time there is a falling edge coming from push button, from sensor, whatever, I don't care. Every time there is a falling edge, you trigger interrupt subroutine. However, RTI is different. RTI, it doesn't have external pin. RTI is just a timer. So this is something internal inside the microcontroller. There is a timer inside it. This timer should, and this is the CPU, right? So all what you have to do is you have to program the timer. There is no external pin, okay? All what you have to do is it's a timer. You can program the timer. I'm gonna tell you the timer, please, timer, interrupt me every 10 milliseconds, right? So once I do that, this is a configuration part. So I have to configure the timer. So this one is used if you want to generate periodic interrupts. This one should be used if you want to trigger interrupt every time there is a falling edge coming from somewhere. You got what I'm saying? So all what you have to do is, if I tell the timer, please timer, interrupt me every 10 milliseconds. So the timer, so now every 10 milliseconds, interrupt is going to be triggered. In other words, every 10 milliseconds, subroutine is going to be executed. So you have RTI interrupt subroutine, this subroutine is going to be executed every 10 milliseconds. If you program it 10 milliseconds, you can program it 20 or whatever. You got what I'm saying? So now, number one, so RTI means real-time interrupt. This is coming from a timer. So again, I'm going to repeat the same thing I explained to before, guys. If you want to program RTI, you have to use this one here, this one, similar to what I did before. The only difference is that you are going to change the number here. In the last one, I used, I think, FF2, right? As you see here, I used FF2. Again, you can get this number from the table as I explained before. So here for RTI, I'm going to use this one. For IRQ, I have to use this one. For anyone else, I have to use these numbers. Very simple, very simple. So similar to what I did here, guys, in this program, similar to this one, you have to do something like that for RTI, but you have to use this number. This is number one. Number two, you have to ask me, for any interrupt, you have to ask me two questions. Where is the enable bit? Where is the interrupt flag bit? Okay, where is the bit you have to clear? Interrupt flag bit. What is the enable bit here? The enable bit here is this one in this register, CRGINT, okay? Bit number 7, as you see here, okay? So if bit number 7 here, if you write here 1, you enable RTI interrupts. If you write 0, you disable RTI interrupts. That's why if you want to enable, very important thing, because that's what you are going to need in the coming lab. If you want to enable RTI interrupt, just to put one here using bit set. As you see here, guys, use this instruction. This is for enable. If you want to disable interrupts, instead of bit set, please use bit clear, because you are going to clear this bit. Pretty easy, right? So this instruction can be used if you want to enable or disable interrupts from RTI, either bit set or bit clear. Okay, very easy. This is where the enable bit is. Number two, where is the interrupt flag bit? Okay, the interrupt flag bit here in this register, it's in a different register. Okay, this is bit number 7. Okay, so this is where when RTI when a trigger interrupt, it has to put 1 here, and then in the interrupt subroutine you have to put 0. You have to clear it. Is that okay? So how can you clear it? You have to clear it by writing 1. Again, this is how it works. You have to clear it by writing 1. That means you have to use this instruction here. Always in interrupt subroutine of. I didn't do this in IRQ. I told you because this is automatically done in IRQ, but you have to do it in RTI. And every time you just copy paste this one. Okay. So as you see here right now. So for example, yeah, look here. This is the interrupt subroutine for RTI. I have to put this one. And for any interrupt, for any other interrupt other than IRQ, I have to do the same thing as well. Okay, use this one. Okay, I'm gonna continue next time. The last thing but I'm gonna explain next time. The last thing is how can you set the time? That's it. How can you set the time out? Okay, the way you are gonna set the time out, I'm not gonna explain, but it's another register. That's it. So we have this register. You have to put some number here in this register. That's it. So now this one in IRQ, we needed only 1 register, but here we need 3. We need 1 register for enable. We need one bit in a register for enable, and we need 1 bit in a register for interrupt flag bit, and we need another register here to set the time. Okay, so I'm going to explain it next time.